All right, we're going to start with number 5 here. An apple, a really small apple, falls from a tree to the ground. Ignore air resistance. Ooh, so no external work. As soon as I see things like ignore air resistance or, there's no friction, I know, no external work. And take the ground level to be y equals 0. What do they mean by y? Oh, that means the ground level is potential energy is 0, right? So they've already nicely told. And falls from tree. So I'm going to also assume that it starts off without moving, because most apples that I see that fall, as opposed to being thrown, start off from rest. So that's an assumption I'm going to make. And then they want to know all this stuff when the apple's height is only 3 meters above the ground. So on my bar graphs, here, let's see, this is what did I say, number 5? On my bar graphs here, I'm going to do it at 4 meters and at 3 meters. Now, do people have different numbers than 4 and 3? Yeah? Okay. So whatever your starting height is and whatever your ending height is. So I know there's going to be PE graph. So I add that to both sides. And at the beginning I said it wasn't moving, so no kinetic energy. It's going to have a bunch of PE graph, though. In fact, I'm going to give it 8 bars of it. Just making sure I counted. No external work, because they told me don't worry about gravity. Don't worry about air resistance. So as it goes and it gets closer to the Earth, that means it's going to have less PE graph, maybe like 6 bars worth. But for my energy to be conserved, it must have a couple bars worth, therefore, of kinetic energy at that point. So that'd be the correct bar graph for this situation. Good?
Wait, but
Okay, I'll wait. What am I waiting for? Someone told me to wait. I'm okay. So, that bar graph gives us the equation that the PE graph at 4 must equal KE at 4 plus the PE. Oh, sorry, at 3, not 4, 3. At 3. If I grab my equation sheet and say, well, I read off that the kinetic energy is 1/2 inertia speed squared, and potential energy grav is the weight, since that's the gravitational force, and the height it is, h. And now maybe I should look and see what they actually want me to find. Kinetic energy, potential energy, and the total mechanical energy when the apple's height is 3 meters. So, the total energy would be either side of this, right? Because the total energy at 4 is the same as the total energy at 3. And then the KE at 3 would be just substituting in for KE3, and the PE at 3 would just be substituting in. So I think I'm not really going to use this, but it made me hopefully realize that the total energy stays the same. Because what's the only force doing work on this? Gravity, and gravity is internal to the system, right? So it's just shifting the work from one place, the energy from one place to another, not adding it. So I think to get the total, well, I'm going to do it in the order they want it. KE, PE, total. Okay, so KE at 3 would equal 1/2 the mass, 0.25, and oh, do I know the speed at 3? Oh, I don't. I have to find that, so I can't start that way. Can't just throw in the equation. I better, maybe I can figure out potential energies because I know about the heights, right? And potential energy relates to height. I got stuck there because I didn't know the speeds. So let's do PE4. G4. That's the weight, 0.25 kilograms times 9.81 newtons per kilogram. I'm assuming, the other assumption I made is that it took place on the Earth because the Earth's the only one I know that has apples. And then I could do the same for PG3. Oh, and then if I subtract those, I get the KE, right? This one is the total. This one is the total energy, right? If I do PE G4 minus PE G3, that equals KE3. Yeah, this should have been G3 here. Sorry about that. And then I have all the answers. And I just put them in separated by commas. Yeah.
Why is the second breakdown? Why is that the total energy?
Because energy is conserved, so the energy I had at 4 is the same. I could also check it by, well, I can't really because I have to use the PE4 minus 3 to get KE.
Yeah.
If I solve for KE independently, then I could have added them together and checked it. But
So you're just combining what's in that second equation, total E, to get your answer that you're going to be entering in here.
well, it asked me for 3 answers.
Yeah, it has to.
PE at 3, KE.
Wait. Some of the questions are okay, so
PE, KE in total.
yeah.
What's your?
So you actually now
Look at the bottom line.
Oh,
potential minus
Potential at a height at the beginning height of 4 minus the potential at
sorry.
the 3 equals the kinetic energy at the 3.
Okay, so
That's why the bar graph and that first equation are important.